Hello, hello, hello. So, we're going to be looking at more circles today. In the last class, we saw that if we have an equation that's in the form x minus h squared plus y minus k squared equals some constant, r squared, this is going to be an equation that graphs to a circle. Now, one example that we looked at was x minus 2 squared plus y minus 1 squared equals 25. This equation is written in the standard form of a circle, and so just by looking at it, we can tell that its graph is going to be a circle. However, there are other ways to write this equation. We could take x minus 2 squared and we could actually square that out. We could take x minus 2 times x minus 2. If you do that, you end up with x squared minus 4x plus 4. And we could do the same with the y minus 1 squared. If you do that, y minus 1 times y minus 1 is y squared minus 2y plus 1. So we could also write this equation in this form. And I'm going to do one more thing. If we combine these constant terms, 4 plus 1 gives us 5. And what I'm going to do is I'm going to subtract 25 from both sides to move this to the left-hand side. And so what we end up with is x squared minus 4x plus y squared minus 2y minus 20 equals 0. And I just want to point out that these two are equivalent equations, meaning they have the same solution set, meaning they have the same graph. So this right here is going to give us a circle, but also this one is going to give us a circle as well. And in fact, anytime we have an equation in the form x squared plus y squared plus cx plus dy plus f equals 0, this is going to give us a graph of a circle. So I've just done a little bit of rearranging. I put the x squared and the y squared first, and then the constant times x and the constant times y, and then the constant term. But basically, if we have any equation in this form, it's going to give us a circle. If we want to figure out what the circle is going to look like, where the center is and what the radius is, we're going to have to go back and put it in standard form. And the way that we do that is by completing the square. Now, I'm going to go through an example and show you how to do this in just a minute, but I want to point something out. This equation has an x squared and a y squared and some other terms, and this gives us a circle. We saw earlier equations that only had an x squared, like y equals x squared plus 3x minus 4, and that ended up giving us a parabola. So if we just have an x squared, we ended up with a parabola. If we have an x squared plus a y squared, we get a circle. We're going to see some things later, some shapes later in the semester. We're going to have some examples where there's an x squared and a y squared, but they both have coefficients. And in a situation like this, we're going to end up with an ellipse. That's not the best drawing of an ellipse in the world. It should be a little bit more round, but basically an oval shape if the x squared and the y squareds both have coefficients. And then if we ever have an x squared and a negative y squared on the same side, or even a y squared minus x squared, that is going to end up giving us a shape called a hyperbola. And it's going to be something like either this or like this. These are just tiny, tiny sketches. I don't want you to think that this is a beautiful example of a hyperbola. But the reason I'm sharing this with you right now is because I want to show you that We have looked at a couple of different shapes lately. We've looked at parabolas and we've looked at circles. And they seem like things that are very different, but I want to show you that they are similar, right? A parabola has an x squared and then a y somewhere in the equation. For a circle, we've got an x squared and a y squared. So just by changing the equation a little bit and having two different variables squared instead of one, we go from a parabola to a circle. And I want to show you that when we alter things a little bit in the future, like putting coefficients in front of the x squared or the y squared, or having one of those squared variables be negative, we end up getting shapes that are different. We're going to have a chapter later on in the semester where we look at parabolas, circles, ellipses, and hyperbolas, and we look at all of the different equations. We talk about some of the geometric properties of the shapes and things like that. And so we will be tying these different shapes together, even if it seems like they are fairly different. Okay, that's enough of a little tangential discussion for now. What I want to do is I want to do one example together where we complete the squares to see what our graph is going to look like. So let's sketch a graph of the equation x squared plus y squared plus 2x minus 6y plus 6 equals 0. Now our goal is to get this into the standard form for a circle. But to do that, we're going to have something with x squared and something with y squared. And to get to this step, we need perfect trinomial squares, perfect square trinomials. So what we're going to have to do is we're going to have to group the x terms and the y terms together and complete both of those squares. So I'm going to write x squared plus 2x. I'm going to put those together. And then I'm going to leave a little bit of space to complete the square. And then we're going to have plus y squared minus 6y. And then I am going to subtract 6 from both sides. And the reason I'm doing that is just to move the constant to the other side so that it's out of the way, and we can focus on completing the squares with x's and y's. Let's complete the square with the x's. Remember, to do this, we need to take the coefficient of the x, divide by 2, and square it. 2 divided by 2 is 1, and 1 squared is 1. So we need to add 1 to complete that square. But if we do that to the left, we also have to do that to the right. Now with the y's, if we take negative 6 and divide it by 2, that gives us negative 3. And when you square that, that gives you positive 9. So we've got to add 9 there, which means we also have to add 9 onto the other side. Once we've completed the squares, we can go through and factor these. X squared plus 2x plus 1 becomes x plus 1 squared. And then y squared minus 6x, y squared minus 6y plus 9 gives us y minus 3 squared. And then on the right, negative 6 plus 1 plus 9 gives us 4. So now this looks a lot closer to the standard form. X plus 1 squared plus y minus 3 squared equals 4. So we're ready to start graphing this circle. We need to find the center first. The x-coordinate of the center is the thing that's being subtracted from x. In this case, it's going to be negative 1, because adding 1 is the same as subtracting negative 1. The y-coordinate is going to be the thing that's subtracted from y. In this case, that's 3. And then the radius, remember, this constant is the radius squared. So to get the radius, we have to take the square root. The square root of 4 is 2. So we've got a radius of 2. And we're ready to graph this circle. The center is going to be at negative 1, 3. So it's going to be right here. The radius is 2, so we can draw our points for guidelines to the right, above, to the left, and below. And then we need to do our best to draw a circle that goes through those 4 points. And we can label this x squared plus y squared plus 2x minus 6y plus 6 equals 0. We could label it with this equation. I will always label graphs with the original equation because we were asked sketch a graph of this equation, and so I'm labeling it and saying, hey, this equation you asked us to graph has a graph that looks like this. It's also good for your notes because if you're using graph paper that's different from your notebook, if you're using graph paper that you've printed out, for example, then you'll be able to easily match the problem with the graph if they're labeled the same.